Hi, in this video, we're going to be talking about scalars and vectors. Let's start with scalars. A scalar is any quantity that is fully described by magnitude alone. Magnitude just means the amount or the size. So for example, mass can be described by magnitude alone. Temperature, time, power output, all of these measure some amount, and so they can be fully described by just that amount. On the other hand, vectors are quantities that are described fully by both its magnitude and the direction. So you have to include the amount, but also in what direction is it moving or going. So an example of a vector is a force. You always have a force with some amount. You're pushing with some amount of strength, but it's always being pushed in one direction. Could be to the left or to the right or up or down, but there's always a direction. Velocity is the same way. It's speed with a direction. Position always includes the direction, where something is located with respect to a reference point. Let's look at an example of a scalar and a vector. Let's say you're going fishing. All right. And in my lifetime, I've caught a total of 0 fish, but I've been fishing. That's not better. But let's say that you caught a fish, or you're about to catch a fish. It has a mass of 2 kilograms. Now, that 2 kilograms, that fully describes the mass of the fish. But if you're describing how much force you have to pull up on the fish in order to get it out of the water, you have to include a magnitude, how much, 20 newtons of force. You also have to include a direction to fully describe the force. It's not enough to say, I applied a force of 20 newtons on the fish. To fully describe the force that you apply, you include the direction. So 20 newtons, comma, up. You're pulling the fish up out of the water. So to fully describe a vector, you need to include both the magnitude and the direction. Another example of a vector is position. Let's say I've got a number line here, and this number line represents the number of meters between different locations. All right, and so let's say that you've been talking with this girl, and let's say that this girl is just a babe. Okay, and this baby is traveling different directions, and let's say that this baby starts in her chair. Okay, now if this baby turns and sees a ball across the room, I'll try to get out of the way for this. The baby will walk or crawl or slither their way over to the ball, stopping here. Let's say the baby has some fun with the ball, playing around, and then spots from across the room some goldfish. Oh, babies love goldfish. Trust me, I know. And so this baby darts its way over to the goldfish, right? And so it travels across this room. Now, if we were to track the position of the baby over time, you could do this in different ways, but one of the ways that I've done it on purpose here is I set the chair to be our reference point, where we're going to say the position is 0 meters at this chair, like on a number line, the position of 0. Okay, pretty simple so far. If you go from the chair to the ball, you're going from 0 to 3 meters. So over here, the baby is at a position of 3 meters. It gets a little bit more confusing if you say the baby is at a position of negative 2 meters over here. But the negative part doesn't really mean anything about, the kind of position other than it's to the left of the 0. And that's the key thing about physics is when you see a negative sign for a vector like position, the negative really doesn't mean anything other than the direction that it is from our reference point. So if we set 0 to be the chair, the goldfish is to the left of the chair, and so therefore the goldfish is at a position of negative 2 meters. It's 2 meters from the chair, but the negative sign tells us it's to the left of the chair rather than to the right. That's all the negative sign means. And there's a lot of confusion that comes with that because negative means other things in math class, but in physics class, negative just means the direction. It's to the left of the zero. Sometimes negative could mean down or west or whatever it is. Usually it's going to be to the left or going to be down. Negative usually indicates that kind of direction. One more example. Let's say you have 3 identical cars. Well, I tried to draw them identical, but it didn't work out. And they're moving at different velocities. You can represent the velocity of a car in a couple different ways. I have shown it pictorially or graphically over here, and then I've shown it mathematically on the right side. Let's start over here. These 3 cars, this one's moving 20 meters per second forward, this one's moving 10 meters per second forward, and this one's moving 10 meters per second backwards. If you look at the size of the arrows that I drew, remember vectors have to include both the direction and the magnitude. So you can show the direction obviously by arrows, but the magnitude is shown by the size of the arrow. This arrow is twice as long as this one. And so therefore, this is twice as much speed, twice as much magnitude. These 2 arrows are the same size, so they're both 10 for their magnitude. It's just that their direction is different. This one's going forward, this one's going backwards. So how do you represent that with mathematical symbols? The way you do it is over here. So each of these, I've written a V for the velocity. We'll talk more about velocity in a later video. But velocity is speed and direction. And so we say V for velocity, but we also add this little harpoon symbol, that's technically what it's called, above the V to show that it's a vector. The harpoon means it includes the direction. So think arrow, direction, the direction is included. So for this velocity, it's 20 meters per second in the forward direction. So I could write that a couple different ways. I could write it positive 20 meters per second. I could also write it as 20 meters per second, comma, right or forward. Both of those, all of those would be acceptable. I've chosen to use the positive sign to indicate that it's in the positive direction, meaning to the right or to forward. Here we have a positive 10 meters per second, so still in the positive direction. Now for this third car, since it's going in the other direction, we're going to call that the negative direction, left or backwards. So that's going to be a velocity of negative 10 meters per second. So we'll work with this a little bit more. I do want to just point out, I did include the positive signs here, but you don't have to because positive is implied. If it's not written as negative, it's going to be positive. So you could take these out and it would still be just as true. Nothing has changed here. But I like sometimes to include the positive just as an explicit reminder, hey, this measurement includes the direction. It's in the positive direction and not the negative direction. Well, that's all I've got for you in this video. Remember, everything you have is a gift.